We are continuing on with our proofs and different theorems. We'll look at a couple other theorems today that we'll practice proving. So our goal today is we can write proofs about triangles and recognize relationships. So continuing to build on what we've done so far. So in example 1, we have a picture over here on the left. And what about this triangle tells us that this is an isosceles triangle? And isosceles is when we have two sides that are congruent, which is why they have those two sides marked with the same number of tick marks. So those are congruent. So that is why two sides are congruent. But there is a little bit more about isosceles specific triangles. So additional information, if we have two sides that are congruent in an isosceles triangle, we also have two angles. So this angle right here. So those two angles are also congruent. So that will happen with every isosceles triangle that you will ever see. It has two sides that are equal and two angles that are equal as well. So it's important to remember that both of those happen. Okay, so reviewing our triangle sum theorem, which says that the three angles of any triangle add up to 180 degrees. We're going to use that information to determine the values of x and y. And so if we look at our picture over here, we have x's in a lot of places. We only have one y though. So when we're adding our angles together, I can't actually do this one yet because I can't have two different variables in an equation. So we're going to look at the triangle on the left. I have three different expressions here, but they all include the same letter. So let's write our equation for that. So the first angle plus the second angle plus the third angle. So all three angles of our triangle added together equal 180. That's the triangle sum theorem. So then we combine our like terms. So we have x, 3x, and x. So that's 5x altogether. 7 minus 18 minus 9. That will be minus 20. Equals 180. We continue to solve. Add 20 to both sides. And then we divide by 5. So we end up getting x equals 40. Okay. So we have half of this. We have determined the value of x, but we need to continue to go forward and also determine the value of y. So now that we know what x is, now we can jump to this second triangle. So we can set up that second one, and let's actually go over here and figure out that what our two angles are here. So we know that x is 40. So let's plug in a 40. So we get 40 plus 21. So that gives us 61 for that angle, 61 degrees. 40 plus 17 over here. So that gives me 57 degrees for that angle. So that will make our equation a little bit easier when we set it up to solve for y. So now we have 61 plus 57 plus y equals 180. So that's our triangle sum theorem for the second triangle. And that would give me 118 added together plus y equals 180. Then I could minus 118 from both sides, and I end up getting y equals 62. So that is the two pieces of our answer. Okay, so example 3, we're now going to be focusing on what's called the exterior angle. So angle 4 here in this picture is our exterior angle. So looking at this diagram on the left, or on the right, sorry. So this has the same triangle repeated over and over and over and over. It's called a tessellation. So this same triangle, so if I look at this triangle right here, outlined, here to here to here, and compare it to our picture here on the left, so that looks very similar to that. So we're looking at this exterior angle right here, which is these two added together. This is our exterior angle. And if you notice, it's the red and the green pieces together gives me this exterior angle. And we want you to notice that the red and the green also show up inside the triangle. So we have this red one and this green one. And so this is a picture that shows you that these two angles added together are going to be congruent to this big angle, this exterior angle over here on the outside. So that's going to be another theorem that we're going to talk about in a little bit. Okay, so another way we could do this, though, if you don't remember that, we can just use the information we know so far. So this pair of angles right here, we've been talking about for a long time. It's called a linear pair, and we know they add together to be 180. So if I take 180 minus 146, that will give me this angle, which is going to be 34 degrees. And then I can just use the triangle sum theorem again. All three angles of my triangle added together, plus 4y plus 8, plus my third angle, which now I know is 34, equals 180. So always use the information you remember, even if it's not the theorem that comes straight to the top of your mind. Okay, combine like terms, we get 9y plus, adding all three of these other ones together gives me 45 equals 180. We minus 45 from both sides. We have 9y equals 135. Divide by 9. And y equals 15. And is that the end? We have to look at what we're looking for. Find the measure of angle A. So I'm not quite done yet. So because it said, didn't just say solve for y. Find the measure of angle A. So angle A is right here. So this is the measure we're looking for. So let's take that y equals 15 and plug that in. So the measure of angle A is right now is 5y plus 3, but now we know our value of y. So then it's going to be 5 times 15, because that is our y value, plus 3. And that ends up getting us 48 degrees. If I did my calculations right. Let me check that really fast. Nope, 78 degrees. Okay, and there's our final answer. That's what they asked us for, is to find the measure of angle A. Okay, so down here at the bottom, we're going to get back into proofs, and we just want to review all of the things that we've talked about that we can use possible reasons in proof. So over here is how we have our proof set up. We're going to have our statements on the left and our reasoning on the right, and the reasons, we've had a list going. So our first reason is always what we're given, but these are all properties and relationships that we know something about. So vertical angles we know are congruent, substitution properties, subtraction. So this is a big list of things that we've talked about that we can use as reasons in our proofs. So you can always refer back to this, but go ahead and look through that and see if there's things that you remember or need to brush up on, but these are the reasons we're going to be using as we go through our proofs. So the triangle sum theorem, we know what it is over here, is that we have the sum of the interior angles of a triangle add up to 180. So, but in this case, we want to prove that this is true. So our goal is to make sure that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So what we need to do in order to do this is we're going to take this picture and we're actually going to draw in this line right here. This is a parallel line and we are going to make it so. So this is parallel to this side of our triangle. So that's going to be a part of our picture as we go through this proof. So we are given triangle ABC, and we are given to prove that the measure of the interior angles all add up to 180 degrees. So statement, first statement is always what we're given. Triangle ABC, and also that parallel side that we have. So that's our given. Okay. After this point, and anytime you're looking at a proof, you just look for the relationships that you know. And so looking at this picture, because I can't use the triangle sum theorem because that's what I'm trying to prove. So looking at this picture, I have these three angles right here, which form a line. That is a relationship that I know. I don't have to know anything about parallel lines even for that one. So I know that angle 3 plus angle 4 plus angle 5 all add together to equal 180 degrees because it forms a line. So I can't call it a linear pair because there are 3 of them, but they do form a line. Next, let's see, what are some other relationships that we know? So since, let's move on to our parallel. So if those two sides are parallel, we can look at angle 5 and angle 2. There's a relationship there. So we know that they are actually congruent to each other. Angle 2 is congruent to angle 5. And we know that because they are, if we look at our parallel lines, they are alternate interior angles. And the same can be said for angle 1 and angle 4. So they're just on a different transversal. So we can also say angle 4 is congruent to angle 1 for the same reason, alternate interior angles. Okay, now we have a couple different equations here, and don't forget what our goal is. We want to say that angle 1 plus angle 2 plus angle 3 equals 180 degrees. So we do have this, this is our statement we're trying to prove here. So we do have this equation, which is equal to 180 degrees. We already have angle 3 there, which is good, but let's see if we can use these other equations we've come up with. So it looks like I can take angle 1 and substitute that in for angle 4. And it looks like I can take angle 2 and substitute that in for angle 5. So let's rewrite that statement. Angle 3 plus, instead of 4, I can say angle 1. And instead of angle 5, I can say angle 2 equals 180 degrees. And that is the statement I am trying to prove. So we got to that step by using substitution. And there's the end of our proof. Okay, so this is the theorem I mentioned earlier, our exterior angle theorem. So this theorem says that any exterior angle of a triangle is equal to the sum of the opposite interior angles. So 4 is our exterior angle. So measure of angle 4 equals the two opposite interiors. So 1 and 2 together is going to equal the measure of angle 4. So the measure of angle 1 plus the measure of angle 2 equals angle 4. And that is what we were trying to prove in this statement, okay? So there's no given statement, but we are given the picture. So there's no statement, but we are given a picture with those labeled numbers on there. 1, 2, 3, and 4, those 4 angles that we're looking at, we're going to be using. So again, let's look for some relationships that we do know. I know this relationship right here, angle 3 and 4. Angle 3 plus angle 4, I know add up to 180 degrees because they are a linear pair. Do we know any other relationships? I know, like, of this triangle altogether, I know that those 3 angles, 1, 2, and 3, add up to 180 degrees because of the triangle sum theorem. And can I now use, I have 2 equations and I only need 2 equations in order to use substitution usually. So it looks like this equation is equal to 180 and this equation is equal to 180. So that means I can set them equal to each other since they're both equal to the same thing. Equals 3 plus angle 4. So that's going to be my substitution. And remember, always remember the goal of where you're trying to get. So I want to get to measure of angle 1 equals plus 2 equals the measure of angle 4. And it looks like I can get there because I can just subtract measure of angle 3 from both sides. And that will leave me with what I'm trying to prove. So that happened from subtraction. And that's the proof of the exterior angle theorem. Okay. let's talk a little bit more about isosceles triangles. So we have a theorem for these as well, which is exactly the same statements as what we talked about before. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. And the converse statement is if we originally have two angles of a triangle that are congruent, we can then imply or state that the opposite sides to those angles are congruent as well. So jumping to example 4, let's solve for x and y. So we have two pictures here. So it looks like our two angles are congruent, and we know that these two sides are congruent. And it looks like we have some extra information. We have some information down here, but we don't really know how long that side is going to be. But I know that these two are going to be equal, and that is enough for me to be able to solve for x. So I know that 2x minus 1 equals x plus 7 because of they're the two congruent sides of our isosceles triangle. So now I have x minus 1 equals 7 because I gathered my like terms to the same side, added 1. I have x equals 8. So I've done the first part of what I was asked to do. Now let's jump over to this right triangle. So here's a different situation, still an isosceles. So it only has marked that these two sides are congruent, but because of our isosceles triangle theorem, I know that these two angles are also congruent. So if I know that these are congruent, I automatically know that this x value also equals 72. So I have my x value there. And then if I know this is 72 and this angle is 72, then I can use my triangle sum theorem, because I know 72 plus whatever my y value is going to give me 180 degrees, because all three angles of a triangle add to 180. So that gives me 144 plus y. We minus 144 from both sides equals 36. So we solve for x and y on that one. Okay. Moving along, in this picture, we're going to use the theorems that we've been talking about for some different proofs. So we have a new triangle ABC. We have some exterior angles, it looks like, some other relationships. But our goal is to prove, we are given that the triangle is isosceles, and that's marked on there. We are trying to prove that angle 1 is congruent to angle 4. So again, with the statement, make sure you just copy and paste the statement you're given. ABC is isosceles. Nothing changes from what you're given to what you write as your statement. And that is given to us. Okay, now we look for some other relationships that we know. So we could say that angle 1 and angle 2, there's a relationship that we know. So angle 1 is congruent to angle 2. And the relationship between those two is that they are vertical angles. We can also say the same thing with angle 3 and angle 4. Those are also vertical angles. So we can say that they are congruent as well. Another relationship that we know is angle 2 and angle 3. And we know that because we are given in the beginning that the triangle ABC is isosceles, which means if two sides are the same, two angles are also the same. So angle 2, we can say, is congruent to angle 3 because it's an isosceles triangle. Okay. And then we have to make our goal from there. So we're looking to say that, trying to prove that angle 1 is congruent to angle 4. So we have a lot of different things here. I can start replacing, substituting. I couldn't substitute anything with these two because they didn't have anything in common. But now I have this, so let's see if I can substitute anything here. So it looks like I can take 1 and substitute it in here. So I can say angle 1 is congruent to angle 3. So I replaced this 2 with the 1. So that was a substitution. And getting closer. Okay, so now I can say also I can take angle 4 and that is congruent to angle 3, so I can plug that in on this side. So I could say angle 1 is congruent to angle 4, and that's exactly the statement that I wanted to prove. So that last step was by substitution, if I can spell this right. Substitution, there we go. Okay, so there we go. Next, we are supposed to be proving that the measure of angle 1 plus the measure of angle 3 plus the measure of angle 5 equals 180. So again, we start with, it doesn't look like we have a statement, a given statement. So we're going to say the picture is what we are given. And again, anytime you are unsure of where to start, look at your picture and look at the relationships that you know. So like in this case, we know, just like last time, we know angle 1 and angle 2 are vertical, angle 4, angle 5 are vertical as well. We have some vertical angles. We don't have any parallel lines, but we still have relationships. We have a triangle in there, so I know the angles in there all add up to 180. So let's start with just one thing at a time. So angle 1 is congruent to angle 2 because they're vertical. And then we have also angle 4 is congruent to angle 5, also because they're vertical. So just put some marks there. We also know that angle 2 plus angle 3 plus angle 4, all of our angles inside of the triangle add together to equal 180, and that is from our triangle sum theorem. Okay, and this is, again, focus on what is the statement I am trying to prove. So I want measure of angle 1, 3, and 5. So now I have a couple different equations, so hopefully I can do a little bit of substitution here. So in the equation that has 2, 3, and 4 equal to 180, my 2 I can replace with a 1, and the 4 I can replace with a 5, and let's see what that gives us. So this becomes angle 1 plus angle 3 plus angle 5 equals 180, and that was from substitution. And that is exactly what I wanted to prove. So now we're done with that one. So look for the relationships that you know, that you can recognize and that you know something about. What are their congruent ones? Are they supplementary, complementary? Okay. Next, we have parallel lines this time. So we're probably going to be introducing some of our like alternate exterior, interior, corresponding, some of those relationships into our proof this time. So the only thing we are given is that C is parallel to D, so we can go ahead and write that as our first statement. You can always do that automatically. Just copy and paste that given statement. And the reason is we are given that information. Okay, information we know. So looking at this picture, what do we got? We are trying to prove that angle 1 and angle 2 added together equal the measure of angle 5. Okay. So the few things that we know. So we have a triangle. We can start there. There are lots of different places you can start. I'm going to start there, plus angle 3. So the angles of my triangle I'll add together to be 180 degrees. I have a relationship here as well. I have 3 and 4. So angle 3 plus angle 4 also equals 180, but that is because they are a linear pair. Oh, I forgot to write my reason. So this is the triangle sum theorem. And angle 3 equals angle 4. That is because they are a linear pair. I'll put a better written up version of this on Canvas. And then we also have, let's see, our parallel, we have angle 4 and angle 5. Because of our parallel lines, we can say angle 4 is congruent to angle 5 because they are corresponding. Corresponding angles. So now I have quite a few equations that I can plug things into. So let's go with, let's use this equation right here. So we have angle 5 and angle 4, so I can substitute this 5 for that 4. There's nowhere else I can really use that substitution, so let's rewrite that. Angle 3 plus angle 5 equals 180. And then let's use this equation and this equation. Since they are both equal to 180, we can say that they're equal to each other. So angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 5. So that was our substitution. Oh, this was substitution as well. Okay, and then our very last step, we're at the end. So we have an equation where we can minus the angle 3 from both sides, and then we'll end up with what we are looking for. Angle 1 plus angle 2. Again, we're not being super particular about the measure, having the m's there. And we get that from subtraction. We just subtracted angle 3 from both sides. And that gave us our final proof. Okay, practice 3 on this one, we're given a few things. We have parallel lines here. And we also know that BC equals CD, those two segments, and that's all marked on our chart. So they've given us the first, written down the first step. That is our given, always, is our first reason. And then we know angle 1 is congruent to angle 2 because we have to come up with a relationship. How do we know that those two are congruent? That is because they are part of an isosceles triangle. All right, and then next we know angle 3 is congruent to angle 1. Also, in the same statement, 2 is congruent to angle 4. Okay, so we can say that that is because of the parallel lines. And so the relationship between both of those is that they are corresponding pairs. Corresponding angles. Okay, and then we know from there that angle 3 equals angle 2 is congruent to angle 2. It looks like we could take this statement right here and this statement right here, and we could take angle 2. It looks like we plugged in angle 2 right there, so that was the substitution step. And then finally from there, it looks like angle 2 somehow transferred into angle 4, and that looks like it because of here. We can take that angle 4 and plug it in right there, and that will give us our last step as well. Substitution. And that's the end of that one. Okay, and our last practice here. So we're given only that we have two parallel lines. So I'm going to write that automatically down. That is my first statement. Okay, so parallel lines, we're trying to prove that angle 1, measure of angle 1 plus measure of angle 2 equals the measure of angle 5. This is very similar to one of our other statements. But let's just write down the relationships that we know. So I have my triangle. So I can say that those three angles of my triangle add together to be 180 plus angle 3 equals 180. Okay, and that is my triangle sum theorem. Okay, other relationships. I have 3 and 4 right there, which is a linear pair. So I can say angle 3 plus angle 4 also equals 180. Because they are a linear pair. And let's see, what else do I know? I have my parallel lines, so probably some relationship with the parallel angle. So it looks like 5 and 4 is going to be my relationship. So 5 and 4, those are congruent as well, plus angle 4. Oh, sorry, they're congruent, which means I put a congruent symbol in between. Okay, so this, I have 2 that are congruent to each other, so I can plug that into something else. So perhaps I could plug this in for that angle 4 right there. Oh, sorry, let's write our reason down for angle 5, why they're congruent to each other. And this is because they are alternate exterior angles. So this is one of our perpendicular relationships. Okay, alternate exterior angles. So we rewrite this. We're going to plug in that angle 5. So angle 3 plus, instead of angle 4, we're now going to plug in an angle 5 equals 180. So there is a substitution step. Okay, and then again, let's use this, this equation that we just came up with, and this equation, which is also equal to 180. And I'm using that one because I need to somehow at some point involve measure of angle 1 and angle 2 to get what I'm trying to prove. So we continue. Those are equal to 180, both of them, so I can set them equal to each other. So angle 2 plus angle 3 equals this last one that I have, angle 3 plus angle 5, also by substitution. Okay, and it looks like we have angle 3 on both sides, so I can subtract that, and I end up getting the statement that I'm looking for, that I'm trying to prove. So they're equal to angle 5. And that, our last step, was a subtraction.